Hi students, good morning one and all present here. Myself Revathi, working as an assistant professor in the Department of Electrical and Electronics Engineering, KPRIET Institute of Engineering and Technology, Coimbatore. Today we are going to see applications of semiconductor devices under the basics of electrical engineering. Uh, First of all, what do you mean by rectifier? It is an electronic device that converts AC into DC. That is, it is converting alternating current into direct current. The process of converting AC to DC is called rectification. So a PN junction diode is a primary component that is used as a rectifier. So you have studied PN junction diode. So under forward bias, so it is working as a closed switch. Under reverse bias, it is working as an open switch. So rectifiers are broadly classified into two types. One is half wave rectifier and full wave rectifier. So let us see one by one. Both half wave and full wave rectifiers consist of PN junction diodes. Here rectifiers are widely used in electrical as well as in electronic circuits. So these are the parameters which we have to study under rectifier. So forward current, it is the current flowing through the forward based diode. So peak inverse voltage, so it is the maximum reverse voltage that a diode can withstand without destroying the junction. Reverse current or leakage current, that is the current that flows through a reverse based diode. So first we are going to see the half wave rectifier. So half wave rectifier is it consists of only one PN diode. These circuits are used to describe the conversion of AC signals into DC in power supplies. So diode rectifier gives an alternating voltage which pulsates in accordance with the time. Here the filter is used for smoothing the pulsation in the voltage and to produce pure DC voltage. And regulator is used which removes the ripples. In half wave rectifier, as we have seen already, one half of the each input cycle is rectified. When the PN junction diode is forward biased, it gives little resistance, and when it is reverse biased, it provides high resistance. During one half cycle, the diode is forward biased when the input voltage is applied, and in the opposite half cycle, it is reverse biased. So during alternate half cycles, the optimum result can be obtained. So this is the input voltage, and this is the symbol of PN junction diode. This we have seen already, and this is the output from the half wave rectifier. That is, we get pulsating DC voltage. So half wave rectifier is an electronic device that is used to convert alternating current into direct current, as we have said already. So it allows either a positive or negative half cycle of AC to pass and blocks the other half cycle. So half wave rectifier selectively allows only one half cycle of the input voltage to pass through that produce a pulsating DC across the load resistor. So during one half cycle, the diode gets forward biased when the input voltage is applied, and in the opposite half cycle, it is reverse biased. Therefore, the output waveform produced by the half wave rectifier consists of ripples of positive half cycle, and it is called the pulsating DC. In a half wave rectifier, PN junction diode is used as a rectifier. So working, so the AC supply is connected in series to a PN junction diode and a load resistor. It consists of two half cycles, one is positive half cycle and the other one is negative half cycle. In the positive half cycle, the diode gets forward biased and hence it acts like a short circuit. That is, it acts as a closed switch. Therefore, in positive half cycle, current flows through the circuit and produces whole AC input as such in the DC output. In the real world, the output voltage is less than the input voltage, considering the diode voltage drop. So during negative half cycle, the diode gets reverse biased and hence it acts like an open circuit, that is open switch. Therefore, in the negative half cycle, current does not flow through the circuit and output does not consist of input negative half cycle. Input we are applying in the input side. So this is a transformer, that is step down transformer. Here it is the PN junction diode. So we have only one PN junction diode in the half-wave rectifier, and this is the load resistance. So when we are applying input AC voltage like this, so we get the output like a pulsating DC. So during the positive half cycle, the diode gets forward biased and it acts as a short circuit. That is, it acts like a closed switch. Therefore, the output follows the input. During negative half cycle, the diode gets reverse biased and it is acting like a open switch. Therefore, no current flows through the circuit. Therefore, the output voltage is 0. Next half cycle, again the diode gets forward biased and it acts like a closed switch. Therefore, the output follows the input. So it goes like this. So the output contains ripples. Therefore, we are in need of filters to smoothing out the ripples. Though again, when a positive half cycle comes, which is passed through the diode and it is visible in the output waveform. After that, negative half cycle comes and it is blocked by the diode and it is not present in the output. This process continues to convert AC into DC. In a half-wave rectifier with a filter circuit, the diode is connected in series to a capacitor and load resistor, which are in turn connected parallelly as shown in the above circuit diagram. Here the capacitor charges in the positive half cycle and discharges through the negative half cycle, and it reduces ripple in the output. In the positive half cycle, the diode acts as a short circuit as we discussed already, and the capacitor charges from the input source. In the negative half cycle, when the diode acts as an open circuit, the capacitor discharges providing the current flow into the loop. So during positive half cycle, the capacitor charges from the input, and during negative half, the capacitor discharges providing the current flow from the load into the source side. Thus adding a capacitor to the circuit, it helps to maintain DC output even when AC is in negative half cycle. So here the input is applied like this through the step down transformer. Here during the positive half cycle, the diode conducts and it acts as a closed switch. Here the capacitor is connected parallel to the load resistor. So during positive half, the diode acts as a closed switch and the capacitor charges during the positive half and it follows the output like this. During the negative half cycle, the diode gets reverse biased. At that time, the capacitor discharges the voltage to the source side. Therefore, it gets the output like this. So this is the output of the half-wave rectifier with the filter circuit with capacitive filter. Advantages of half-wave rectifier. It is simple since it has lower number of components and it is cheaper as there is less equipment. Although there is a higher cost over time due to increased power losses. Disadvantages or drawbacks. It allows only a half cycle through the sine wave and the other half cycle is wasted. This leads to power loss. So it produces a low output voltage. Here the output current contains lot of ripples. Applications of half-wave rectifier. So in the first slide itself we have seen. So it is used for rectification applications that converts AC into DC. There is alternating current into direct current. So this is used for signal demodulation applications. So these are the advantages, disadvantages and applications of half-wave rectifier.